Yes, so that's one thing you have to be able to do. Okay? One thing that I'm emphasizing this chapter with all this stuff, absolutely don't fall behind. Just don't fall behind. If you don't know how to find a vertex by now, you're in trouble. Okay? So make sure that if you're stuck on something, if you don't quite understand, I can help you out. Okay. So here we go. So this one, lots of practice. 1, 2, 3, 4, 5, 6. So we had actually 10 finding vertex problems from an equation. My favorite are the last two, because those you actually start to see how some of this stuff might be used, rather than just graphing a little picture, or something like that. But let's answer the burning question. What is one problem that rocket scientist Dr. Awkward never has? Do you get it? Because if you look at his name backwards, it's Dr. Awkward. Excuse me. Okay. So at this point in time, you need to be able to find a vertex. Okay. So here's what we're going to do. We're going to do some practice problems. And that's not what I wanted. Okay, I'm going to take this. I'm going to put this over here. Oh, you need one, don't you? Okay. 4 graphs, 2-word problems. And I am interested in making your life as easy as possible while we're doing this. So here we go. Let's graph y equals x squared plus 4x minus 1. We know it's going to be a parabola. Oh, I put the extras up front there on the corner. Okay? We know it's going to be a parabola because it's got an x squared. Anything where you just have y equals and then an x squared, it's going to be a parabola. Okay? Here, for interest, I don't know if you're interested, but if I would have x equals something with y squared, it would open to the side. Kind of an interesting little deal, but we don't talk about that in this particular class. So here we go. Let's find the vertex. Opposite of b over 2a equals negative 2. So here's how I like to do mine. I'll just go ahead and plug it into each individual part and write them down. Negative 2 squared, 4. 4 times negative 2, negative 8. Negative 1. I add them together, and I get negative 5. So negative 2, negative 5. Oh, there's something I forgot to do. There's some important stuff about parabolas that I did not leave space for. So let's go way up top here, and let's write this. Y equals ax squared plus bx plus c. I want to talk real briefly about what a does to my graph, what b does to my graph, and what c does to my graph, because they each change it in their own unique way. Okay? The first thing, let's have a little study about a. You don't need to get this worksheet out, but I want to use it as an example. Here we go. 3 opened up. Negative 3 opened down. 1/2 opened up. Negative 1/2 opened down. So what's your hypothesis?
If it's negative, it opens down.
Yep. If it's negative, it opens down. If it's positive, it opens up. Let's write that. So if a is greater than 0, it opens up. Okay. If a is less than 0, it opens down. Okay. That's kind of the basics. You'll notice the one equation last night when you're finding the maximum height of, I think, the gerbil you were throwing. Is that right? Oh, no, it's a ball. Sorry. It was negative 16. So because picture the path, it's opening down. Okay? Okay. Let's take a look at what else A does. Well, A, here's what I consider kind of my standard parabola. Let's zoom out just a little bit. Out, out, out. There you go. This is my standard parabola. This one, how would you compare this one to this? It is what? What adjective would you use? Stretched. Okay. Narrower, thinner, skinnier, something like that. So if I change from a 1 to a 3, what really happens is it goes, stretches it vertically. So it makes it taller and thinner. So what happens is when A is bigger than 1, like say this 2, it's been stretched up vertically. And you'll see that a little bit more later on. So let's go, if A is greater than 1, it is taller, thinner. Is thinner have two ends? I think it does. It just didn't look right. I know the English rules say it is. Okay. But what if A is less than 1, like 1/2? There you go. Good. Like this one is shorter and fatter. Okay. If A is less than 1, it's shorter, wider. If you prefer fatter, that's fine. But I'm going to add one thing to this, and there's a reason. It doesn't matter if it's negative or positive, it's still thin. It doesn't matter if it's negative or positive, it's still wide. Here you go. It doesn't matter if it's negative or positive, it's still thin. So what can I put around this A to say that I don't care whether it's positive or negative? Absolute value, technically. Technically. Okay. I'm not going to be able to explain exactly how, but B, what that does is it slides it left and right. But if B's 5, it may not be 5. So we're not going to go there too much. I'm just going to say that it moves it left-right. This C, what it does, it moves it up and down. Matter of fact, this C is my y-intercept. C is always my y-intercept. That's a nice little checkpoint to see if we've done some things right. Okay. So now, I got a little excited to graph, and I forgot to put all that stuff on there. So now let's get back to where we were. So I've plugged in I found my negative B over 2A, plugged that in, got my different parts, add them together, I got negative 5. Okay. So are you interested in the slow, tedious way or the fast way? Now give it some thought. Give it some thought. Do you want the slow, tedious way or the fast way?
Fast way.
Yeah. I'm interested in the fast way also. Okay? Not because it's faster, well, partially because it's faster, but I think it's much more elegant. It's much more of a neat solution. If you want to know where to plot it at -1, you could go back up to your equation and put in -1. If you want to know where to put it at 1, you could plug it in 1. At 2, I could put it in 2. 3, put in 3. That sounds kind of boring to me. And it's just the same thing over and over and over again. So here's what we're going to do, is we're going to apply our knowledge and our common sense to look at this graph right here. This is the standard parabola with 1x squared. Everything that's 1x squared looks exactly the same. It might just be located in a different spot. But when I say looks exactly the same, here's what I'm talking about. Observe. To get from my vertex to my first point, I go over 1, up 1. To get to my next point, I go over 1 and up 3. My next one, I go over 1 and up 5. If I had more graph here, it would be over 1 and up how much? 7. Okay, now some of you guys might be like, well, why is that? Why do our parabolas look like that? Well, take a look at our squares over here that I wrote down. Here's my perfect squares. 0, 1, 4, 9, 16, 25, and 36. We all know those. Look at how quickly they grow. This one grew 1 unit, grows 3 units, grows 5 units, grows 7. That's why that's going on. Because as we square things, we lose our one-to-one correspondence that we had when it was a line. When we square things, okay, things start to change a little faster. So what happens is our slope is changing as we go up. And what we can do with this right here is we can just take advantage of this over 1 up 1, over 1 up 3, over 1 up 5 deal and get a ton of points really quick. So here we go. From this point right here. I'm going to pretend like I totally forgot what I just said. How do I find other points? What do I do from here? Over 1 and then up 1 to start with. Okay? Over 1 and up 1. From that point, over 1 and up 3. From that point, over 1 and up 5. I don't need to do my over and up on the other side. I could, but what I can do instead is I can just go ahead and fold it over my line of symmetry. 1 unit away on the other side. 2 units away on the other side. 3 units away on the other side. And then I just make my nice, pretty parabolas. And I don't put a point at the bottom. I put a nice curve. What a beautiful parabola. My mom would be so proud. For my first math job, my mom got me this math tie that had all these math things on it. She thought it was pretty cool. I thought it was neat. Okay? And now notice one thing we can double check. Look at this. That's my y-intercept. Yeah, that's my y-intercept. Yeah, they should match. And they does. Here we go. Let's do the next one. See if we can continue to get better at this. So the opposite of B over 2 times A is 3. Oh, by the way, I messed this problem up. This plus 8, we need to cross that out and let's turn it into a minus 8. Turn that into a minus 8. Oops. You'll see why here in just a second. So if I plug in 3, I get negative 9, 18. Again, is this something you were doing on your assignment last night? Yeah, so you should be good at this by now. Okay? And then we have minus 8. So if I wouldn't have made that change, it would have been up at 17, which is a little bit off my paper. So 3, 1. How's this one going to look? Open down. Why? It's a negative. Okay. Okay. So now this one, it's still a 1. It's going to be shaped the same exact way that we did before. Over 1, down 1, over 1, down 3, over 1, down 5. Go. From that point, all these 1s, 3s, and 5s, it's from the last point you drew, not from your vertex. There we go. Now, you guys have graphed these things before in Algebra 1, correct? Okay. Did you guys just plug in values to get other points, do you think? Do you remember? Okay. Okay. So you might ask this question, what if that's not 1, Mr. Rexroad? Well, that's a great question. Let's go to this down here. Let's make it a 2 and see what happens. Let's find my vertex, the opposite of B, over 2A equals -1. Now, I have messed this next part up in both classes. I'm going to have to take my time and think about what I'm doing here. -1 squared is 1 times 2 gives me 2. -1 times 4 minus 4 plus 1 should give me -1. I'm just plugging in the value like you did last night on your homework. I always like to plot my axis of symmetry. By the way, the equation of that axis of symmetry would just be x equals -1. Okay, so is this one going to look exactly the same as the last one?
No.
Because this 2, it's positive, so it's going to open up, but it's also going to be stretched vertically. It's going to be stretched vertically. So I used to go over 1 and up 1.
Over 1 up 2.
Exactly. So I'm going to go over 1 and up 2. After that point, I used to go over 1 and up 3. What am I going to do in this one? Over 1 up 3 times 2, so it'll be 6. And by that point, we are off of our graph. And you'll see it does make something that is taller, thinner. Okay? And it does have my y-intercept of 1. So that kind of confirms what's going on. So you'll notice, I'll put this in bold here because it's pretty important. Typically we do this. Over 1 up 1, over 1 up 3, over 1 up 5. That's what we typically do. But when it is stretched or compressed or whatever, I just took each one of my rises times 2 instead. Okay. Ready for one last parabola? You're like, yeah, please be done with these parabolas. Here we go. -b over 2a. To something. Let's find out what my something is. 4 times -3 is -12. 24. -5. -7. No, it's +7. Duh. Okay. What did I do? Weird. Okay. So this one going to open up or down? Down. I usually go over 1, down 1. What am I going to do here? Down 3, because it's 3 times as much. It's been it's times 3. And I usually, after that point, go over 1, down 3. But now I'm going to go over 1 and down 9, because it's 3 times as much. You guys are doing awesome. I wasn't sure if this is the way I wanted to teach this, but I'm so happy that you guys are doing well. So there we go. Okay. So I think graphing, we'll have some fine points we might need to add in tomorrow. On your assignment, they're going to ask about domain and range. Don't worry about domain and range today. I'll talk about that a little bit tomorrow. Okay? For now, let's move to the back. Okay. So as a business, your goal should be to provide a service. But your goal also should be to make as much money as you can while you're providing that service. Okay? So here's the situation. You'll have to laugh at this. I was frustrated that my clock wasn't changed because I thought they were all embedded in the system. And I thought they would change automatically. What? Oh, yeah. Yep. And then I finally realized that no, that clock is just hanging on the wall. It's not connected to a school system at all. Here I am on day 2. Why don't they change my clock? Well, because you can do it yourself, you knucklehead. Because in some schools, it's all controlled from the office. Anyway, so here we go. A ski resort has extended hours on one holiday weekend per year. Last year, they sold 680 ski passes at $120 per holiday weekend pass. Stop. Don't do anything else. I'm going to do something here to get you guys familiar with what's going on. You don't have to do this every problem. Okay? But let me convince you what's going on. So we have a number of passes and a certain price. So right now there's 680 passes at $120. Could we figure out what their revenue is, how much money they're bringing in? What do I do with these two things to find out how much revenue they brought in? I just multiply. $120 passes, 680 of them. So I multiply them together, and I get $81,600. That's a pretty good haul from a weekend. But I don't know what their expenses are. Who knows? Okay? And again, you don't have to do this next step if you're doing it on your own, but I'm trying to show you what's happening. It says this year the resort is considering a price increase. What's going to happen if you increase your price on the most part? You're going to sell more or less? Probably going to sell less. Okay? Even though that doesn't work for Dollar General. They raise their prices and I still buy. It's awful. I know, exactly. Okay, so here's what's going to happen. $5 increase, so this might turn into $125. They're going to sell 2 fewer passes. And let's see if they're on the right track. 660 times 125, 82,500. So they are making more money. So it seems like that was maybe a wise choice. I would argue, though, that that's going to be 20 less people buying hot chocolate, buying food, all that good stuff, renting skis, so maybe, I don't know. But that's a whole nother ballgame. So then you're tempted, should I raise it some more? And should I raise it some more? Well, we're going to do the algebra and find out if we should raise it some more. So here we go. Our price was $120, and I'm going to raise it $5 for every increase. That is a new way to express its price in terms of I, the number of increases. Okay? What's going to be the number of passes then? How would I write that? 680, help me out. Minus 20 for every increase in price. And that's going to be their amount of money they brought in. Okay? Gee, does this look familiar to something you were doing last night? Maybe multiplying things out? I kind of wonder why I gave you that, to make sure we could do that. So let's go ahead and multiply this out, shall we? I'm going to write this in typical quadratic form with my squared term first when I combine my like terms.
Sorry.
What was that?
I had a hiccup, but I was trying to hold it in.
Okay. So there's my quadratic formula that's going to give me the relationship between money and how many increases I have. Okay? So if I want to find out what is going to be my maximum, gee, what should I do? Find the what? Yeah, can we shut that, please? I like to have it open to get some fresh air, but...
I wonder if
Children are loud.
I wonder why.
Okay. Okay. So what should I find? Vertex. So go to the opposite of B over 2A equals 5. So that tells me I should have 5 increases in pay. Or in price, I mean. Okay. So now we should also answer the question, since we can, what is that maximum price? Well, there's 2 ways to do this. You've got 2 equations. You've got this long equation there we could plug 5 into, or we could find out how many passes we would sell and what the price of those passes would be and multiply both of those things together. So you could either plug in 5 to this bottom line, or you could plug in 5 up here and find out how many, what your prices are and how many you're going to sell. I'm going to plug it in up here. That's just my preference. 580 passes at 145. You'll get the same answer if you do it a different way. 580 times 145. $84,100 dollarinos. So just by analyzing this and making this change, they made $2,500 more dollars. Okay? And I'll tell you a little story here real quick. I used to work at one of the larger Honda dealerships in the state of Nebraska. It was large enough where we had, I think at the time, 11 different mechanics, and most mechanics had 2, maybe 3 bays. So we had a ton of bays. I think we had like 30 hoists. It was crazy. And my whole job was they would drive it. The customer would drop off a car, and then we'd figure out, okay, what do you want done? And then I would park it out in the parking lot. And we did like 90 cars a day. And they'd all show up in the morning. So my job was to take the car out of the parking lot, take the car out of the parking lot, take the car out of the parking lot. And then when the mechanic was ready for it, they'd say, I need a car runner. And I'd go up, grab the deal. I'd tell me what car it was and what mechanic to take it to, and I would drive it to them. And that's all I did all day. Okay? My boss, he was really good. He was so good that Honda said, we want you to make a film for us on how to be a good repair dealership. And he found out I was a math major, He goes, I want to show you how I'm making this decision that I'm getting ready to make. And I'm like, okay. And the stuff that he had done, the statistics and the math that he was doing on a decision that he was going to make for the dealership, I was like, whoa, people actually do this stuff if they're really good at what they do. I was surprised. I was honestly surprised. Okay, here we go. So for this next one, you don't have to do the first two steps like I did. If you can go right to this, by all means, do so. Okay? So that's my challenge to you on this next one, is I want you to come up with two expressions. One that is how many seats they're selling for the concert and how much it is per seat. Last year, a ticket provider sold 1,350 lawn seats for a concert at $70 per ticket. This year, the provider is considering increasing the price. They estimate that for every $2 increase in price, they will sell 30 fewer tickets. How much should the ticket provider charge in order to maximize profit? Just see if you don't have to multiply this one out. I'll just show you I'll show you the work on it. Just fill this in. You don't have to worry about multiplying it out. Okay? Remember, one of these is going to express how many tickets. And the other one's going to be cost per ticket. Do 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 do. Do, 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 do. And where's my other sheet so I can show you that? Maybe I throwed it away. No, it's right here. Still have people working and writing. Okay, tickets. How many tickets are we going to sell? How are we going to express that? What should I write? 1,350. 30i. You can use whatever variable you want, but you have to use the same variable for both. I use I because that change happened because I increased the price. 70 plus 2 I. There you go. So we would do the same process. We would multiply it out, find negative b over 2a, and hocus pocus, there we go. It would happen after 5. You don't have to write all this down. The big hard part about it, I think, is writing this to start with, and the rest of it are the skills that you've already established that you have. And this is why it's so critical to not get behind. If you can't multiply these things out like we worked on, well, that's why you got to come in for help if you're struggling. Okay? If you can't find a vertex, well, it makes the next step awfully tough. Okay, so here's what we're going to do today. 149, 2, 3, 5 through 8, 11, and 12. 2, 3, 5, and 6 are graphs. Please do a good job with those graphs. I don't care which style of graph paper you use. It doesn't make a difference to me. And 11 and 12 are problems just like we just got done doing there. That's kind of short. 8 problems?
I think it's a long.
I knew that was coming.
I'm sorry, I was waiting for the rest.
No, I didn't know who it was. I wasn't saying.
It wasn't I.
Yeah, well, I appreciate your patience.
I was looking to use the restroom. Oh, really? In case
Oh, is it really? No. Oh, I canceled one.
Do I have to make a new one?
I'll take care of it. I was ready to click and then it moved it down. And you know how it does like on your phone sometimes?
So can you stop my passport? That's what you what X is.
And happy birthday. How old are you? 16, 17? 17. All right. So when you turn 17, what can you do that you couldn't do before? Is it R-rated movie you can go see finally? I have no idea.
I think you could have already seen those. I think it's like nothing.
I don't know.
I think you get nothing parental supervision.
Yeah, but by yourself.
By yourself? Probably like 16. What do you mean? What are we talking about?
We're trying to figure out if there's anything that have you. Yeah, 17. You must be 17 years old. So now you can go to R-rated movie without your parents.
Actually, I don't like R-rated movies, so.
Yeah. Yep. I'm just saying that is you've now passed over that threshold of maturity. That you can handle that for some reason. No, that's a good point.
Yeah, me either. I'm not sure about that either. What? It's the opposite. So it's a negative, then it's a positive. Yeah. Out of the three numbers that you find, how do you find the first one? Like
I suppose I should stop this video, huh?